Section 1.5, measuring and constructing angles. A lot more vocab here. You can see the entire front page here is vocab, and very, very important vocab in section 1.5. Vocab you're going to need for the remainder of Geometry 1 and also the second semester of geometry. So the first word is an angle. An angle, technically, two rays that have the same starting point. It looks like this. You see there's an arrow here, there's an arrow here. Those are both rays, and they start at the same point here. This point here is called the vertex. The other two parts are called the sides. So that's a side, and that's a side. Two sides, one vertex. Now, naming the angle is very, very, very important. If you know the correct answer, but you don't know how to actually say it, then it doesn't matter that much that you know the answer because you can't express it. So, to name an angle, say this is A, then you have a point B, and you have a point C. There's several ways to name it. First of all, you could just call it angle A. And as long as there's only one angle coming from A, you can just call it angle A. However, the better way is to use 3 letters. So the question is, if you had to draw this angle without picking up your pencil, you would probably do exactly what I just did, which was go down and then across. You might go the opposite direction, but you're going to start at the end, go toward A, and then go back out. The way to name your angle with 3 letters is to list the letters in the order you would trace if you were doing that. So if you went this way, the first letter you would hit would be B, then you would hit A, then you would hit C. Angle BAC. But as I said, some people draw their angles like this. They would hit C first, and then A, and then B. C, A, B. These two right here, it doesn't matter which one you use. They are the same angle, it's just whether you're reading it in one direction or the other. Naming the angles, this right here, very, very important. Alright, the interior or exterior of an angle. You guys probably have heard the words interior and exterior before. Interior means inside, exterior means outside. If you have an angle, same thing. The interior is inside and the exterior is outside the angle. The measure of an angle. So, how do we, if we were measuring your height, we might talk about, feet and inches. If we were measuring how far you drove, we might talk about miles. But how do you measure how big an angle is? Well, the degree of an angle is how open the angle is. Is the angle, does it look like this, or does it look like this? It doesn't matter how long the sides are, it matters how open it is. Is it a skinny angle, or say maybe a bigger angle, a wider angle? So we measure it with something called degrees, and maybe this is a 45-degree angle. That little symbol right there is the degree symbol. It's a little circle, a superscript, a tiny little circle higher than everything else. So let's say this was angle XYZ. We would say the measure of angle XYZ, or you could say ZYX, is equal to 45 degrees. Now we use something called a protractor to measure it and figure out that number of degrees, and I'll show you what those look like on the next page. Congruent angles are two angles that have the same measure. So let's say this is angle A, and this is angle B. And angle A and angle B are both, I don't know, let's say 20 degrees. Then angle A and angle B are congruent. It doesn't matter that A is facing one direction and B is facing the other. We would say angle A is congruent to angle B. And in your picture, you can, if you remember back to a previous section where we put little tick marks to show things were equal in length, here it's a little swoosh and a little swoosh. Sometimes we put tick marks on those swooshes. If there was a third angle that was maybe bigger, we could do a swoosh with two tick marks so that it looks different than these. An angle bisector is a ray that divides an angle into two equal parts. So remember, to bisect is to cut into two pieces. An angle bisector cuts the angle into two pieces. So there's an angle that's been cut in half. This piece and this piece would be congruent. This in the middle is the angle bisector. It is a ray that cuts the bigger piece in half. An acute angle is an angle that is less than 90 degrees. It's going to look something like this. I remember acute as like cute things. When I think of cute things, I think of cute puppies and cute kittens and cute babies and little angles, little things. A right angle is an angle that is exactly 90 degrees. It's going to look like this. These are all around you. It's the corner of your paper. It's the corner of your table. It's the corner in the room that you're sitting in. It's the directions trees grow from the ground and the direction that flowers grow from the ground. Right angle, straight up, straight down. And we put a little symbol here in the corner. That symbol right there is the symbol for 90 degrees. Now, it could also go this direction and still be 90 degrees. It doesn't have to be straight up and down, but we're talking about something that could be turned to be vertical and horizontal. An obtuse angle is more than 90 and less than 180. These are going to look more like this. They're going to be slightly wider angles. For me, I personally, I remember obtuse because obtuse is not only a math word, and it is a math word here, but it's also just a word. Sometimes people can call someone else obtuse. It means that you're not very sharp, essentially, that your brain's moving maybe a little bit slow at that moment, having trouble figuring something out or having trouble seeing something. It means you're not sharp. So an acute angle, if you look at it, this looks very sharp, and the obtuse angle is actually kind of dull. If this was, say, the edge of a knife or a saw or something of that sort, this wouldn't do a very good job. It's not very sharp. So obtuse means kind of dull, and this is kind of dull also. A straight angle is an angle whose measure is 180 degrees. It looks like this. Now you would probably have some points here, A, B, and C, and this would be angle B, or angle ABC, or angle CBA. It's a straight angle, it's 180 degrees. Something to remember here is that a straight line is 180 degrees because of the straight angle. Last vocab, or last thing you need to know at the beginning, is the angle addition postulate. Now remember, the segment addition postulate, I talked about this, was if this segment is 2 and this segment is 3, the whole segment is 5. The angle addition postulate is the same idea. If this is a 40-degree angle and this is a 50-degree angle, and let's say this is A, B, C, D. Now the trick is when you add those two together, 40 plus 50 is 90, but when you put the two angles together, you get this bigger angle. This one. That's the one you need to name. So how would you draw this angle? You would start at A, you would go to B, then you would go to C. The measure of angle A, B, D would be 90 degrees. So example 1, find the degree measure of each angle and classify acute, right, or obtuse. So angle AOB. AOB. We're talking about this little angle on the right side. So you see, angle A starts at 0 or 180. The line to B crosses at 35 or 145. See, the inside numbers are getting bigger and the outside numbers are getting smaller. So what you need to do in order to find the size of angle or the measure of angle AOB is you need to find the difference between those numbers. So you can go in whatever order you want as long as you make your final answer positive once you're done. I usually like to do the bigger number minus the smaller. And here I'm going to take the 35 minus the 0. 35 minus 0 gives us an answer of 35 degrees. Now let's do AOC. AOC. That's this bigger angle here. So A again is at 0, whereas C is at 65. So 65 minus 0, 65 degrees. BOC, BOC. That's just this part of the angle. So B crossed at 35, C crossed at 65. So subtract. 65 minus 35, 30 degrees. Now COE. C, O to E. Go in the order that they're listed. C to O to E. It's this angle here. So let's see here. C is at 65. E, now we have to choose. We can choose 35 or we can choose 145. You want to stay consistent whether you are on inside or outside numbers. So when I said 65, I was using the inside numbers. So I need to use the 145. 145 minus 65, 80 degrees. Finally, COD, that's this angle right here in the green. C was at 65. D, remember again, use the inside numbers, 110. So 110 minus 65, 45 degrees. Now the other thing is we need to classify them as acute, right, or obtuse. So let's do right first. Right angles are anything that is 90 degrees. Are any of them 90 degrees? No. Acute. Those are the angles that are less than 90. Are any of these less than 90 degrees? Smaller than 90, smaller than 90, smaller than 90, smaller than 90, smaller than 90. These are all acute. Example 2, name 3 different angles using 2 names for each angle. Alright, so we have 2 angles, we have 3 angles in this picture actually. The first one is this kind of smaller one here. Right there in orange. So to name that orange angle, use 3 letters. If you were to draw it, which letter would you touch first? E, then F, then G. What if you drew the other directions? You would hit G, F, and then E. Notice the vertex is always the middle letter. Alright, next angle, let's do the bottom one. The green angle. Alright, what's the first letter you would touch if you drew it? You would hit G, and then F, and then H. Angle G, F, H. What about the other direction? You would come to H, then F, then G. Notice the vertex angle F, the pointy part of your angle is always in the middle. The third angle, where is it? Well, the third angle is the big angle, the orange and the green together. Kind of the big purple angle here. So let's see here. If you were to draw this one, what would be the first letter? E, and then F, and then H. And the opposite direction, H, F, E. Now, none of these allow you to just say angle F, because if I said just angle F, you have 3 options. You could be talking about the orange, the green, or the purple one. You have to use 3 letters in these cases to name the angles. The way I'm using color here, I highly recommend it. Typically, I would be using highlighters if this was my own, like if I was in class, I would be having my students use highlighters. Since we're not in the school, all of my highlighters are there, so I'm using a box of crayons that belong to my son to draw these angles. You could use colored pens, you could use crayons, markers, whatever you've got lying around the house. Example 3, find the measure of angle JKL. Where is JKL? Starts at J, goes to K, goes to L. JKL is the whole angle. So, angle addition postulate says if we know the little pieces that make the big piece, you add them together. 31 plus 85, 116 degrees. Example 4, the measure of angle RSU is 91. Find the measure of angle RST. A lot of math, in my opinion, is just going back and rereading things a little more carefully. So let's look at this again. The measure of angle RSU. Where is RSU? Start at R, go to S, go to U. RSU is the entire picture. It's the entire angle. We are looking for RST. Where is that? R to S to T. We are looking for the blue part. So the entire angle is 91. The whole orange piece is 91. We're looking for the blue part. What we do know here is that this piece here is 69. That's the part that we actually don't want. If we could just cut that piece off, we would have the blue angle left over. So if you're trying to do something, or if you have a piece that you don't want, you can subtract, take it away. 91 minus 69. 22 degrees. This is very similar. We had something that was like this type of problem where the whole length is 10, this piece is 2, and we said you take it away and you would get 8 because 10 minus 2 is 8. We're doing the same thing. This is called segment addition. This is called angle addition. Here, find the measure of angle CAD. Where is CAD? CAD. That's what we're looking for. Now the problem here is that they tell us it's x plus 15, but we actually need a number. So we know this one's 5x plus 57. We know this one's x plus 15. What else do they tell you? There's something here that you need to find, that you need to see, and what you might be missing is right here. What's that symbol mean in the corner? That symbol means it is a right angle. That means it is 90 degrees. And what we know, we've done similar problems with segments. We know that these two pieces together make the 90 degrees. So how do you do together in math class? You add them. So we can take the x plus the 15, and we can add the 5x plus the 57. And equal it to the 90 degrees that we know it is. We know it's 90 degrees because of the little symbol in the corner. Now you have something you can solve. Let's combine like terms. X plus 5x. Notice the x's are both on the left side of the equal sign, so you combine them. You do not subtract x from here and here. 1x plus 5x's is 6x. Same thing goes for the 15 and the 57. They are on the same side of the equal sign, so you combine them. 15 plus 57 is 72, and equal it to 90. Now you can subtract the 72 from both sides. 6x is equal to 18. Divide both sides by 6, and x equals 3. Now be sure to actually go back and answer the question though. We were not looking for x, we were looking for the measure of angle CAD. CAD. Plug it in. CAD was x plus 15. We know what x is. X was 3. 3 plus 15. We get an answer of 18 degrees. Example 6. QR bisects angle PQS. Find the measure of angle RQS. All right, again, what are we looking at? We're looking for RQS. Start at R, go to Q, go to S. We are looking for that piece right there. Now it's kind of similar to this one, except this one told us that they add to 90 degrees, and this one doesn't tell us that. And in fact, it looks like the whole thing is obtuse, more than 90 degrees. So there's something else here that we need to find, and it's right here, the word bisect. Bisect means the big angle PQS has been cut into two equal pieces. The left side and the right side are congruent. Well, if they're equal, then you can set them equal. 4x minus 10 is equal to negative 3x plus 130. And solve. So I'm going to add 3x to both sides. 7x minus 10 equals 130. I do want to see every step. So if you're capable of solving this in your head, if you're capable of solving it with only one step of work, that's great. But for this class, show every step. Divide both sides by 7. 140 divided by 7, x equals 20. Great, we haven't answered the question yet though, because the question was to find the measure of angle RQS. We found x. So you plug it in. And let's plug it in to negative 3x plus 130. Plug in x equals 20. Negative 3 times 20 plus 130. Order of operations, do the multiplication first. 3 times 20 is 60, so it's negative 60 because of the negative sign, plus 130. 70 degrees. Now, I plugged it into negative 3x plus 130. You could have also plugged it into 4x minus 10 because we know that they should give you the same answer. So if this is a 70 degree angle, this one is also a 70 degree angle. What if I wanted you to find the measure of angle PQS of the whole thing? If I wanted the whole angle, you would need to do 70 plus 70 to get 140. Now one more hint just as you go off to work on the homework. We are not, the constructions on the back, we're not doing those. Those require a compass, which you may or may not have at your house. Something to remember. You can add or subtract the angles. If they together make 90 degrees, add them together and equal it to 90. If you have a bisector, set the two sides equal. But what if, as one extra example, you have something that looks like this, and maybe this is x plus 10 and this is x minus 14. What do we know about this one? What was the word for this, where they make a straight line? That's called a straight angle, and that's when they add, or when the angle is 180 degrees. So it's very similar to this, where they added up to 90. In this picture, they don't add to 90, they add up to 180 because the angle is straight. That should be enough to go ahead and complete the homework for section 1.5.